Hi everybody, welcome back to Chem 330 discussion on week 1 material. And if you remember vividly, the last time I left you all with 2 questions to complete. Okay, one of them was, okay, I had you come up with structural isomers for 2 of these compounds, and one of them actually I didn't give you the number of hydrogens, and I have you figure it out, and you probably guessed that was the answer, and that is correct. And the second one was this. Okay, I'm still going to work out only for this today, and I'm still going to have you give it a shot on the second one. All right, so C6H14. All right, that means we have 6 carbons and 14 hydrogens, right? And as I always said, you start with the straight chain structural isomer first. So we got 6 carbons, and if you remember the discussion that we had earlier, that we have to have 4 bonds for each carbon. So that means the remainder of these 3 bonds would be occupied by a hydrogen, and we're going to go ahead and do the same for the remainder of the carbons, right? Very good. Okay. Now I suggested that while it might be good idea to start doing this for the straight chain structural or fundamental isomer, okay, this is the fundamental or the parent isomer for this particular compound, okay, I wouldn't recommend you do this open structure for all of the other isomers because visually it's very crowding and you may not be able to keep track of all the carbon and hydrogens. But if you still think you'll be able to do it and you find that method easy and you're confident that you will not mistake, by all means help yourself to that. But however, I am just going to condense this into the condensed form, so it will be CH3, CH2, 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 and CH3. There we go. This itself makes one of the isomers, so that's one. Okay, now when you begin to write isomers, I'll teach you a tip, and this is foolproof and most likely it would never let you down. All right, now the only one option that you can go directly from here is to reduce the number of carbons. Now I went from 6 to 5, you can see that's the most logical sense. Now I'm going to switch colors here simply because I want to do something that will probably help you visually. Okay, now we still have to put that 1 carbon. I would not put it on the terminal carbons simply because you're going to recreate this. Okay, so you never put whatever number of carbons left on the terminal simply because you're going to recreate one of the other structures that you may already have created. All right, with that said, now I can put the carbon here. Okay, let me go back and get my, and so I'm going to erase this right here, okay, because I don't need it. Okay, and then I can also create one more, okay, where I am going to write my 5 carbons again, but this time again you don't want to put it in the terminal. Now these 2 are different, okay, they're not the same, okay, they're not the same. So this counts as the second isomer and this counts as the third isomer. All right, let's do one more just to point out why you can have this. Now you may have started on this side, then if you end up with this, that is same as this one right here. Okay, this is same as this, it's on the second carbon, except this time you're going from right to left and then this is left to right. Okay, so this is not another isomer. Okay, that's it, you're done. You don't have any more place to go with the 5 carbon system. Let's keep going. All right, so now instead of 5, your likely option would be to go to 4. Again, I'm going to get my red color. Okay, you don't want to put the remaining 2 carbons on the terminal. Even if you put both of them here or one here and here, you're still going to end up with one of this that you have already created. Okay, so let me go ahead and erase that. We don't need those X's. We don't need the we don't need the X's. All right, let me go get my pen back. Now I can only put it in the terminal. Now I have 2 left, so there's 2 options I can do. I can put them here, or let me get my pen. I can put them this way. Okay, one here, one here. Now you would think, hey, can I do it on this? Well, that will be same as this, because here this time I started from right to left. If you had started left to right, if you started from right to left, it would be here. So that's it. We are done. So this would have been our 3rd, 4th isomer. Okay. And this right here is a 5th. That's it. We're done with our 4 carbon system. Let's go to 3. Okay. Let's go to 3. I'm going to do that here because this pen seems to act up when it's at the very edge of it. Now, I've already told you, okay, you cannot put it on the edge, right? All right, now I have to put 3 carbons. The only logical place would be to put all 3 here. Now we know, now this carbon has 5 bonds. As I said, carbon cannot have 5 bonds. It can only have 4 bonds. So we are officially done with our isomer search. This is the TSA checkpoint I was saying. That's it. You can't go any further until you get checked up by the TSA staff, right? All right, that means how many isomers do we have? We have a total of 5. Okay, now if you do it systematically just like I have done, chances are you're not going to mess this up. Okay, this is a very simple stuff, but the only way you're going to complicate yourself is if you want to make it complicated on yourself. All right, so that's just a review before we start our material for continuing discussion on alkanes and its stereochemistry. All right, let's stop.